In the last video, we did Arrhenius equation. Arrhenius equation was K equal to A e to the power minus Ea over RT, where we know K is rate constant, A is Arrhenius factor or frequency factor or pre-exponential factor we can say, Ea is activation energy, R universal gas constant and E is the temperature. This reaction is mathematically used to find out the effect of temperature on rate of the reaction. On deriving this for solution, we had applied natural law, so it becomes ln K equal to ln A minus Ea over RT. And then we used different temperatures T1 and T2 and then finally derived effect of temperature. But today we have to draw the graph. If we don't draw the graph between ln K versus 1 upon T, so ln K is Y, 1 upon T is X. Between Y and X we have plotted the graph. So what type of graph should come? Because here M, according to straight line equation, M is minus E over R. So it means negative slope. This will be the graph. And slope as it is seen from the equation minus Ea over R. While this intercept will be ln A. This is the graph for Arrhenius equation with natural law, and if we change it into the other equation, that is base 10 log K equal to log A minus Ea over 2.303 RT. This will get converted. And then if we want to plot the graph, we'll get log K versus 1 upon T. Again negative slope, but it will be now minus Ea over 2.303 R. And this intercept will be log A. Now the next topic, after Arrhenius equation, we can take collision theory. For rates of the reactions. To understand rate of the reaction, this theory was derived. And according to this theory, whenever reactant molecules collide with each other, they form product. Now, collisions. What about collisions? With every collision, product will not form. Product will be formed when collisions are proper. So, what is meant by proper collisions? First thing, frequency of collision. Frequency of collision of reactant molecules should be optimum. Optimum, it means if they are colliding with less frequency, they will not able to form the product. So frequency of collision, this we can say this is the number of collisions per unit time, or we can say per second, per unit volume. Simply we can also say number of collisions per second per unit volume. They are known as that is known as frequency of collision. And in the equation for collision theory, it is denoted by Z. That we will denote it afterwards. Second thing, very important thing is there, if frequency of collision is optimum, it's okay. But if orientation of molecules is not proper, orientation of reactant molecules should be proper. Proper orientation, it means from which side they have to make the bond, they should be collide or impact should be from those sides only. Otherwise, the product will not be formed. And this factor in the equation is denoted by P. Now, if we write equation of collision theory, it is given as K equal to Z AB P e to the power minus EA over RT, or PZAB e to the power minus EA over RT. In any way it can be written. K equal to P ZAB e to the power minus EA over RT, where P is proper orientation, ZAB is the collision frequency of reactant molecules which are A and B. That is, if reaction is A plus B, they are colliding together to form product. For this we are talking about. Now the thing is that with the help of example, we should understand the orientation factor actually. For example, I am taking one example of CH3Br molecule, means methyl bromide, reacting with alkali. Hydroxyl ions are reacting there. These hydroxyl ions, they attack on this methyl bromide, methanol is formed, and bromide ions, they are removed, or if it is NaOH or KOH, then sodium or potassium bromide is formed. Now, when they will react together, there are two ways of their orientation. We have to check which is proper orientation. If orientation is like this, and collisions are going on between them, then no product will be formed. Because OH negative ions, they have to form bond with the carbon, and if they collide with each other, then it will collide with bromide group, and it has not to make bond with the bromide group, it has to make bond with the carbon group or carbon atom. So what is proper orientation? Proper orientation is this: if they are colliding with each other, they have to collide in such a way from this side. This is proper orientation. If OH negative ions, they collide with methyl bromide, and in such a way they collide that it collides with the carbon atom directly, then only product will be formed. Now these are fruitful collisions. Here this is proper orientation, and frequency of collision is improper, optimum, then product will be formed. How? This OH will collide with this, and a transition state comes where this OH, it reacts or it makes bond with the carbon, and bond of bromine will be, bromide group will be broken down, and after this transition state, final product is formed where OH get bonded to carbon. So these are the two factors which are very important. This is not proper orientation. This is proper orientation, and this orientation factor is denoted by P. Frequency of collision by Z. This is known as collision theory.